Hey guys, today we're going to continue taking a look at solving systems of equations. Yesterday we took a look at solving systems by graphing, so graphing the two lines and finding their point of intersection. Today we're going to take a look at an algebraic method, and it's called substitution. I've had some feedback on my videos. Some people find it difficult because they can't see me. So I'm just going to include a picture of myself here that you can look at while I'm speaking to you. Okay, so one of the issues with graphing is that it's not accurate. If there's an issue in graphing our lines, as some of you found in class today, then it only really gives an estimate of the answer. And there are two methods that we can use to solve systems using algebra. One of them is called substitution. So we've got our two equations here, and we're trying to solve for t and r in these two equations. And the nice thing is that in equation 2, we're actually told what t is equal to. So what's nice is that we can take that t equals 15r and put it into equation 1 where the t is. So equation 1 is now going to look like this. 15r plus r equals 480. So I can write that because the second equation tells me that t equals 15r, so I can replace the t in the first equation with 15r. So now that we've replaced the t, we have only one variable, and I forgot to write the r. Make sure you can see my face here. Okay, that's good. So you can see now we only have an r in this equation. The t's gone but because we've substituted in. So now we have to solve that equation for r. So if I add the 15r and the 1r together, that's going to give me 16r. And then to solve for r, I move the 16 to the other side of the equation, and I divide. And when I divide, I end up with r equals 30. So we've got an answer for one of the variables. Now I just need to sub that into one of the equations up above to find the solution for the other variable. So I'm going to use the easiest equation up above, which is t equals 15r. And I'm going to plug the 30 in where the r is. And I get an answer of t equals 450. Now to check my answer, I'm going to check it in equation 1 from up above. So equation 1 from up above is t plus r equals 480. So remember, I can do left side and right side to check equations for solutions. So I'm going to put t plus r on the left side, 480 on the right side. I substitute the 450 in for the t. I substitute the 30 in for the r. And when I add them together, I get 480. And on the other side, I already have 480. So I actually don't have to do anything. I could say left side equals right side, and just put a check mark to show that that's correct. I need to check it in both equations. So the other equation in the beginning was t equals 15r. T equals 15r. Left side and right side. T and 15r. So t is equal to 450. Replace the r with the 30. And 15 times 30 is 450. So just as I expected, that point works in both equations. You won't always have to do that check, but it's nice to know that you can make that check. Okay, so we're going to try a different one here. in the first example, we had an equation that was solved for one of the variables. Here we don't have an equation that tells us exactly what y is or exactly what x is. So what we need to do is rearrange the equation. So I'm going to take equation 1, 3x minus y equals 18, and I'm going to rearrange that to get y by itself. So if I move the 3x to the other side, it becomes minus 3x. And if I divide everything by negative 1 to get rid of the negative in front of the y, I have now solved for y in equation 1. I'm going to call that equation 3 because it's a different form of the equation up above, so I don't want to mix those up, so I'll call that equation 3. Okay? And when I look at those equations, y was the easiest one to solve for because I didn't have to divide by a number in front of the y. All right, so now that I've done that, I need to sub y equals negative 18 plus 3x into equation 2. So up above in equation 2, I've got 5x minus 4y equals 23. It's important to use brackets when we substitute expressions in. So notice I just put a bracket after the 4, and then instead of the y, I've got minus 18 plus 3x from up above. Okay, so remember I have to distribute the minus 4 inside the bracket here. So minus 4 times minus 18 is plus 72, and minus 4 times 3x is going to be minus 12x. So just like we found in the last example, I've got one variable x now that I just need to solve for. So I collect the like terms. I'm going to keep the x terms on the left side. I'll take the plus 72 to the other side. It becomes minus 72. And then my last step will be to divide negative 49 by negative 7. So I get x equals 7 as my answer there. It's really going to be important when you do these questions that you don't think you're finished once you find that first variable. Remember that you need a point of intersection as your answer. So now we're going to sub x equals 7 into one of our equations up above. So I'm going to choose equation 3. Equation 3 is nice because we've already got the y by itself. So it looks like that. So I'm going to put the 7 in for the x. And I end up with y equals 3. So at the end, just like yesterday, therefore, point of intersection is, and remember the y comes first, sorry, the x comes first, and the y comes second. So my point of intersection is 7, 3. All right, let's take a look at the check here. Okay? So for our check, we need to rewrite our point there. So the point that we're trying to check is the point 7, 3. So in equation 1, I put 7 in for x, I put 3 in for y, I get 18, and you can see that these two are equal to each other. So that's good. And in the other equation, 5x minus 4y on the left side, 23 on the right. It's going to look like that when we substitute it in. So 35 minus 12 It's a miracle. So just as we expected, that point works in both equations just like it should. Okay, so let's take a look at this one here. I'm going to number my equations again. So I've got, I'm going to solve for x in equation 2. So if I do that, x minus 4y equals 4. And if I move that minus 4y to the other side, I get x equals 4 plus 4y. I'm going to call that equation 3. And I'm going to sub equation 3 into equation 1. It's important that I sub it into the other equation that I haven't worked with yet. So if I sub that into 1, equation 1 is x plus 2y equals 10. So I am replacing the x with 4 plus 4y. And now you can see that we only have one variable, which is exactly what we want. So I'm going to collect the like terms. I don't have to do anything with the bracket here. It's just all adding. So I'm going to end up with 4y plus 2y on the left, 10, and the plus 4 goes the other side, and it's minus 4. So I have 6y equals 6. So I end up with y equals 1. Then I'm going to sub y equals 1 into one of the equations up above. I'm going to choose equation 2. So equation 2 is x minus 4y equals 4. The 1 goes in where the y is. And in the end, I end up with x equals 8. So therefore, my point of intersection is 8, 1. You have one more equation here. I'm going to get you to try that on your own. So you go ahead and try that on your own. We'll take it up as a warm-up tomorrow and discuss any issues that you might have. Okay? Good luck. We'll see you tomorrow.